Hi, everyone. Welcome to the Data Scientist podcast. Today, I have with us Noah Healy, who is a data scientist who has developed a new and very interesting theory with many different applications. And we're going to be talking more about this on today's episode. So, hi, Noah. Welcome and good morning.
Hello. Yeah, thanks for having me here.
So why don't you introduce yourself? I guess you'll do a better job at it than I'm ever going to do.
Sure. So my name is Noah Healy. I'm a recreational mathematician and started working in the computer field right at the time of the dot-com bust, trained in nuclear engineering, expert in, regular expressions, data analysis, databases, mostly done back office automation stuff. And then around a decade ago, took some time out of work to explore the space of computational mathematics. And after a few years, ran across this new idea in game theory I call negotiation games, and developed this technology out of it.
Great. So maybe you'd like to explain what your theory is about, like on high level terms, and then move on to explain why it's needed.
Sure. So at the high level, many of our businesses, systems, and in like IoT space, we have networking pretty much down to a science. We have large amounts of data being produced, but only small amounts of information. It's easy to sort of get over flooded. It's easy for contradictions to be something that's worth doing, or for actors to not care about what's going on. And so finding accurate consensus is one of the most important tasks that faces people using the modern technology and modern information technology. And so this approach creates a system which can manage that consensus space and create incentives that allow both humans and computers to work together to find these high value consensus targets.
And where have you applied this?
Well, my company is based around the notion of building a commodity marketplace price discovery mechanism structured off of that. In consulting, I have talked to people who are mostly in the crypto space and are trying to launch new marketplaces and are interested in new market mechanisms, and with things like DAOs and those sorts of organizations, new mechanisms for operating a system autonomously and collectively. So those are the sorts of applications right now of this.
That's very interesting. I mean, I'm deeply involved in the area of tokenomics. I was one of the first researchers to take this seriously back in 2017. And I've been a big proponent of using agent-based models to model token economies. Is this like approach similar, or is it more based on traditional game theory, like these matrices with trade-offs, or something in between?
It's very much a foot in both of those camps. This is based out of the concept of evolutionary game theory, where in sort of a traditional matrix game theory type structure, if instead of just having a limited number of players, you have a large number of players within each role. So the existing marketplaces are essentially a game of buyers and sellers. And I have turned that from a 2-player game into a 4-player game of producers, consumers, forecasters, and the market operator, where the operator can simply be a computer program that performs its actions so that everybody else can live in a better equilibrium.
Okay, that's interesting. Maybe you can give us some examples of where this could be applied in blockchain. I mean, blockchain is an area I'm deeply involved in, and I personally like, besides tokenomics, anything relating to financial applications of blockchain, for example, decentralized finance. I don't know if you think your theory can be applied there, maybe borrowing, lending, or more exotic financial products. What's your take on that?
Yes, so I'm convinced that existing financial products can't really serve the needs that society has for them, because the buyer-seller model depends too much on this sort of speed-based punishment, which computers allow people with enough money to essentially avoid. So the traditional market structure, somebody that attempts to give false information to the marketplace can succeed, but they run the risk of somebody catching them out when they're sort of in the wrong position. But with the speed of computers and communication, if you can afford a clean enough and close enough connection, then essentially you will never find yourself in the position of being caught out because you are always able to act first. And that stops the regulatory mechanism that allows markets to presently function. So this proposes a new regulatory mechanism, based on supply and demand, where one group of people, who can be anybody, proposes essentially a bonding curve that the market can operate off of, and then other people would then use that autonomous market maker, and the people whose collective beliefs propose the bonding curve would receive their income from the profits of the automated market maker. So you have an interest, even as a participant, in making the market function better, because you will, one, earn from having a better functioning marketplace, and two, by trading within a better functioning marketplace, you will be able to find buyers if you're a seller, or sellers if you're a buyer, in a consistent fashion at prices that are economically valuable to you. So that sort of model allows you to get past existing automated market maker problems, where essentially you have to set up an automated market maker, and then if you screw up, which is nearly inevitable, then you get your lunch eaten as people figure out how to game whatever mistake you made. But this would create a system where we can create autonomous market makers on the chain that can be updated in ways that are safe by the marketplace itself, because the individuals making the updates are bearing some of the cost and earning some of the rewards for the deficits and improvements that they impose.
Okay, so just to understand something, because there are many things going on there, and some of what you're suggesting sounds like something which could be used for yield farming, for example. So are you saying that using your theory, you can model this type of systems, or are you talking about, let's say, a particular, let's say, way of bringing these components together? Because I know, for example, that yield farming protocols use optimization, different optimization algorithms, etc. But it sounds like you're describing something at a higher level.
Yes, it is. It's at a higher level. So what this would allow in a yield farming scenario is that those yield farmers could essentially change their business model to acting in the forecasting capacity, have their various expertises integrated together into essentially a super mind that makes the marketplace function even better. And then they could enjoy a higher rate of return with lower risk, by creating a market that functions better rather than farming a market and making it function worse. So that's the sort of basic notion. When it gets past arbitrage. So arbitrage is critically important, but arbitrage is also something that induces fear because everybody's at risk of being sort of on the wrong side of arbitrage. So what this does is it creates this higher level system where people who can usefully reduce the future opportunity for arbitrage can still receive the returns that would be associated with being able to do that arbitrage in the future. So the marketplace as a whole becomes more stable and more useful.
Okay, that's interesting. And are you in the process of applying this? So the primary use case you believe now is blockchain, and are you in the process of applying it there?
I believe that the primary use case is actually for physical markets of commodity product. That's both larger and more useful. However, I'm consulting with people on getting it going, and blockchain has much lower regulatory overhead than traditional marketplaces, and so things are starting in the blockchain space.
Yeah, and I think that in the blockchain space, if you have any theory relating to economic modeling, game theory, you name it, right now it's like a big sandbox. There are all kinds of crazy ideas flying around. Some, I guess, are going to survive. Some will not. But it's definitely worth trying something there. And do you find that most of your work these days focuses around implementing this theory, or do you also find that sometimes you have use for more traditional tools? Maybe what would be your take for someone who's just embarking on data science?
I think for data science and sort of any computer career, you should absolutely run through all the foundational work. Do the math, read the papers. There aren't that many of them. They're all online. They're all freely available. It does take a few years to get through them, but most of them are actually fairly entertaining. A few of them are real slogs. A good place to get started is the Turing Award lectures, which tend to have some really good technical insights in addition to being good after dinner, speeches, so that they're actually engaging. But understanding what things mean and why things are the way they are is absolutely critical to being able to professionally tell other people what things mean and decide how things are going to be.
Yeah, makes sense. And do you find yourself involved much like in machine learning or like statistics these days? What's your take on which set of tools you find to be the most popular when you work with data?
I have found statistics to be much more useful and much more popular, both because it's an easier sell to the management teams that I've worked with, and it's a better fit to the data sets that I've found people actually engage with. Most companies are not web scale, and most companies don't have more than a few interests. And so at that scale, running up a learning application and training it is fairly difficult, and sometimes actually impossible. There just isn't enough information to make that work. Whereas statistics, the difficulty with statistics is that you sort of have to know what you're looking for, and then you have to sort of hope that your distribution belongs to one of the sets of things that are mathematically tractable. But the good news is that lots of stuff does belong to things that are mathematically tractable, like the normal distribution is all over the place. And in terms of knowing what you're looking for, like I said, a lot of businesses actually really only care about a handful of things. So you can go look for them. Half the time, there's nothing there that you can find, but knowing that is useful too. And so you get a lot of mileage out of just basic statistics, unless you get lucky enough to get some people that are really interested in complex decision making takeovers or have really large scale, really data driven businesses.
Yeah, it makes sense. I think it pays off to keep things simple. I not always try to overcomplicate things. Personally, I found sometimes my work swinging across the spectrum from statistics sometimes to machine learning or deep learning other times. But I think I resonate with many of the things that you're saying. So that's great. Thank you. I mean, before we close the interview, how can our listeners find more about you, like LinkedIn, website?
Yes. So I'm Noah Healy on LinkedIn. Google records that I'm the oldest Noah Healy, so most Noah Healys online are me. And then I do have a website at coordisc.com, COORDISC, for coordinated discovery. Those two syllables weren't used by anybody yet, so I snagged them. So yeah, you can learn more about my marketplace ideas at my website there.
Perfect. Thank you, Noah. It's been a pleasure. Have a good rest of the day.
You as well. Thank you.
Thanks, everyone. Thanks for staying here with us. And make sure to check the datascientist.com for more content around AI, data science, and blockchain. Thank you, and we hope to see you again soon. Bye.